Hey guys, so far in chapter 7, we've learned how to multiply polynomials. That's been the biggest thing we've been looking at. Today, we're going to start learning how to go backwards. We're going to take the answer and turn it back into the two sets of parentheses. So today, we're going to start by talking about the GCF. As a reminder, what does GCF stand for? Well, GCF is the greatest common factor. And when you were in elementary school, you did GCF of two numbers. Okay, so let's review that. Okay, what's the GCF of 12 and 28? Greatest common factor. What's the biggest thing that goes into both of those? Okay, hopefully if you're good with your multiplication backs, you can tell me that the GCF of 12 and 28 is 4. If you're not super good with these, there's another way you can do this by listing the factors. So if I list the factors of 12, I have 1 and 12. 2 and 6, 3 and 4. Do the same thing with 28, 1 and 28, 2 and 14, 4 and 7. And then you just look for the biggest number that matches in both. Okay, they both have a 4, so my GCF is 4. Okay, so today we're going to factor a polynomial. Okay, so remember polynomials are like x squared plus 3x plus 5. So, 7, 4, factoring polynomials. Example 1, we're going to find the greatest common factor. So, what is the greatest common factor of the terms of 12x to the 5th plus 8x to the 4th minus 6x cubed? Okay, notice we have numbers and we have letters. So let's start with the numbers. What's the biggest thing that goes into 12, 8, and 6? Well, they're all even. Okay, 4 goes into 12 and 8, but it doesn't go into 6. 6 goes into 6 and 2, but it doesn't go into 8. So the greatest common factor here is 2. So I'm going to pull out a 2. Then I look at my letters. Okay, I have x to the 5th, x to the 4th, x cubed. Okay, x to the 5th is 1, 2, 3, 4, 5 x's. X to the 4th is 4. And x cubed is 3. How many x's do they have in common? They have 3 x's in common. So x cubed is the GCF there. Okay? So that is how you find the greatest common factor. Okay, your turn. Please pause the video and try these two problems. Okay, problem A, 15x squared plus 18. Okay, again, biggest thing that goes into 15 and 18, well, I see 3. Okay, then I check out the letters. I have x squared. Oh, I don't have any x's here. So my GCF is just 3. Okay, again, pause the video. Make sure you try letter B. Letter B, negative 18y to the 4th plus 6y cubed plus 24y squared. Start with numbers. Negative 18, 6, and 24. Well, should be jumping out at you, is 6. Then I do my letters. Y to the 4th, y cubed, y squared. And again, if you need to write out all the y's and figure out how many they have in common, please do so. So y to the 4th, 4 of them, y cubed, y squared. How many do you notice? You should notice all 3 of them have 2 in common. So my GCF is 6y squared. Okay, so why is this helpful? Well, let's consider the polynomial negative 12x cubed plus 18x squared minus 27x. Let's find the GCF. Okay, notice here the first term's negative. When our first term's negative, we like to pull the negative out. Okay, I don't know about you guys, but we like to work with positive numbers. So I know I'm going to pull a negative whatever out. So it goes into 12, 18, and 27. Well, let's see, 12. We got 1 and 12, 2 and 6. Oh, 2 might be good. Oh, wait a minute. 2 doesn't go into 27. Same thing with 6. Okay, 3 and 4 is another way to make 12. Okay, 3 goes into 18, 3 goes into 27. Oh, so 3 is the number. So I'm going to have negative 3. Then I check my letters. Okay, x cubed, x squared, and x. They all have just a plain old x in common. So my GCF is negative 3x. Okay, but now we're going to take it up a notch. Now we're going to factor out the GCF. Okay, so I might know my GCF is negative 3x. I want to know what times negative 3x gives me this entire thing. So I'm going to do parentheses. Okay, what times Actually, hang on, let me just write it down here so I can see it again better. Okay, so this is where we are working backwards. Okay, so what times negative 3 gives me this negative 12? Well, negative 3 times 4. Okay, and if I take one of those x's away, what times x gives me x cubed? Remember when you multiply, you add the exponents. So 1 plus what gives me 3? 2. So x squared is what comes out. I move on to the 18. What times negative 3 gives me a positive 18? Negative 6. I take one of those x's away, how many are left? Just one. Okay, then my last term. What times negative 3 gives me negative 27? Positive 9. And I have one x already. I need one, so I don't need any more. So my answer here is negative 3x times 4x squared minus 6x plus 9. Factoring out the GCF results in a polynomial with smaller coefficients and or smaller exponents. This makes it much easier to analyze the polynomial or continue to factor it further. Okay, so it's very helpful to have a GCF pulled out. Okay, here's two problems. Please pause the video and try these. Okay, letter A, x cubed plus 5x squared minus 22x. Remember, when you don't see a coefficient, it's always 1. So we need to find the biggest number that goes into 1, 5, and 22. Answer is just 1. Look at your x's. I have x cubed, x squared, and x. What do they have in common? Just plain old x. Okay, so now we do parentheses. What is left? What times x gives you x cubed? Well, x squared. What times 1x gives you 5x squared? 1 times 5. X times what gives me x squared? X times x. Okay, and then what times 1 gives me negative 22? Negative 22 times x gives me x. So just leave that alone. So your answer here is 1x or just x times x squared plus 5x minus 20. Again, pause the video, try letter B. Okay, biggest number that goes into negative 16, 28, and negative 20 should be a negative 4. Remember, we pull out a negative version if this is negative. Okay, look at my letters. I have 6, 4, and 3. The most they have in common is 3. Okay, parenthesis, what's left? What times negative 4 gives you negative 16? Positive 4. Okay, if I take 3 of these y's away from the 6, I have 3 left over. Okay, what times negative 4 gives you positive 28? Negative 7. I have 4 and I took 3 away, so I have 1 y left. And what times negative 4 gives you negative 20? Positive 5. I had 3 y's, I took 3 away, so I don't have any more y's. The answer is negative 4y cubed times parentheses 4y cubed minus 7y plus 5. Okay, so let's start looking at an application problem. Alani is in charge of marketing for a travel company. She is designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. So there's 2 main square photos, which each have a length of x. Okay, so I know this is x, and I know this side is x. Okay, same thing with this square picture down here. Then we have 4 narrower photos that are each 1 inch by x inches. So this is 1, this is x. This is 1, this is x. Same thing here. Okay, so what's the total area of each type of photo? So we need to find the area of each type. Well, what's the total area of the photos? So let's find the area of each little part. How do I find area? Length times width. Okay, so my square photos, area equals side squared. How long is my side on this square? Well, it's just x. So my area here is x squared. And how many of those do I have? I have 2. So I have 2x squared. Now for the rectangles, area equals length times width. Okay, how long is it? X. And how wide is it? 1. So area equals 1x. And how many of those do I have? 1, 2, 3, 4. So it's really 4x. So total means add. So my total area is 2x squared plus 4x. Okay, so I know I have 2x squared plus 4x. Okay, so let's find a rectangular arrangement for the photos. What factoring represents this arrangement? Well, how long is this side? Remember that was x. And this side was also x, and then these were each 1. So really, I can break down this 2x squared plus 4x into length times width. My length here is x times, how many x's here? 1, 2, and then a 4. Okay, does that make sense? Yeah, exactly. If I go back through it, that becomes 2x squared plus 4x. So this is one way you can factor. However, is this the greatest way to find it? Let's find out. Okay, so let's factor out the GCF. So I had 2x squared plus 4x. Remember, GCF, got to look at the number and the letter. Okay, so it goes into 2 and 4. 2 does. Okay, x squared and x, how many do I have in common? Just a plain old x. So 2x times what gives me 2x squared? Well, I need another x. And 2x times what gives me 4x? Well, I need a 2 there. So really, this represents 2x times x plus 2. So if we think about this in terms of the picture, okay, 2x would be the square photos, okay, because this is x and this is x. And then the other one would be x plus 2. Well, here's my x, right? If I'm going this way, here's my x, and I need 2 now. So here's 1, and here's another one. So the rectangle pictures. So this is how you would look at it if you were to factor the GCF. Okay, so that's what I have for today. Factoring polynomials, we always look for the GCF. Okay, remember GCF, you have to look at the numbers first, and you have to look at the letters. So homework tonight, you're going to be on page 285. You're going to do problems 20, 21, 26 through 33. As always, if you have any questions, please let me know. Hope you guys have a good day.